In our previous lesson, we have looked at how we can decompose rational functions into partial fractions, and we've considered example on the repeated factors. My name is Nanaya Wedu, and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and click on the notification bell so that you can get all videos on time. In this lesson, we want to consider another example on decomposing rational functions into partial fractions, and we want to look at the repeated factor. Let's consider the example. So in this example, it says that resolve 5x plus 4 all over x minus 1, right? And then x plus 2 all square in partial fractions. So let's look at how we can resolve this. So when we look at the question carefully, the question is asking us to resolve the expression 5x plus 4 all over x minus 1, right, s plus 2 all squared. So when we consider these denominators very carefully, you realize that it has a linear factor, right, and then a linear factor that is repeated, right? So the x minus 1 is a linear factor, and then x plus 2 all squared is a linear factor that is repeated. So in that case, we can write the expression 5x plus 4 all over x minus 1 s plus 2 all squared as a all over the factor x minus 1 plus b all over the repeated factor x plus 2 plus c all over x plus 2, right, all squared. So we would write the left hand side again, and then on the right hand side we would find the LCM. So 5x plus 4 all over x minus 1 s plus 2 all squared will be equal to, now when we consider this, we'll see that the LCM would be x minus 1 then x plus 2 all squared, because we realize that for s plus 2 it will go into s plus 2 all squared. So we have x minus 1 and then s plus 2 all squared. So our a, x minus 1 will cancel x minus 1. So we'll be left with x plus 2 all squared, right? Plus b, s plus 2 cancel one of the s plus 2 here. So we are going to have, in this case, x minus 1, then x plus 2. Then we'll have plus c, right? And for c, s plus 2 cancel s plus 2. And then we'll have x minus 1, right? So we say that since the denominators are the same, right, then we equate the numerator. So we have 5x plus 4 to be equal to a s plus 2 all squared plus b x minus 1 s plus 2 plus c x minus 1, right? So that implies that we can consider the factor s plus 2. So s plus 2 can be equal to 0, which is here, right? And it means that x will be equal to negative 2. Now we are going to put x to be equal to negative 2 into the equation. So that implies that we will have, right, 5 multiplying negative 2 plus 4 to be equal to, we see that when we put negative 2 into the a part, it goes to 0, because negative 2 plus 2 gives us 0. Now when we put negative 2 here as well, it goes to 0. So we have only the c part. So we have c, right, negative 2 minus 1. So this time we've gone through the process so much, so you should know that once we put that factor into a and b, because of s plus 2 here, which is the factor that we got the negative 2 from, when we put it there, they become 0. So a and b goes to 0, and we have c to be negative 2 minus 1. So that implies that we'll have 5 multiplying negative 2 gives us 10, right? So we get 10, right? And then we will have plus 4, right, negative 10. So it's 5 multiplying negative 2. So negative 10 plus 4 is equal to negative 3c. So that gives us negative 6 is equal to negative 3c. So we divide both sides by the coefficient of the c, which is negative 3, this side by negative 3. And that implies that our c will be equal to 2. Right, so another factor we have that we can substitute into the equation will be x minus 1. Right, we can equate it to 0. In that case, x will be equal to what? 1. So when we put it into the equation, we are going to have 5 multiplying 1 plus 4 is equal to, right? In this case, we see that a will be 1 plus 2, right, all squared. When we see b, there's x minus 1 here, so it means that the b goes to 0, and then there's x minus 1 here, so 1 minus 1 also goes to 0, so c also goes to 0. So we get 9 here, and then we are going to have 3 all squared a. So 9 is equal to 9a. Right, so we divide both sides by the coefficient of the a, which is 9, and that implies that a becomes equal to 1. Right, so we've exhausted our factors. One of the factors we used was x plus 2, which is here, and we've also used x minus 1. So one of the simple things in this case is that when you exhaust your factors, you can take x to be any number at all. So let's take x to be 0. That's an easier way to be able to probably get the b part that we don't have. So it means that when x is equal to 0, 5 multiplying 0 plus 4 will be equal to, right, the a will be a, 0 plus 2 all squared, plus b will have 0 minus 1. So we are substituting 0 in place of x in all the equation here, and then we will have 0 plus 2, right? Then we have plus c, right, and that will be equal to 0 minus 1. C multiplying 0 minus 1, right? So that will be that. So that implies that you are going to have, right, 0 plus 4, which is s 4. Right, this side gives us 4a. Right, 2 squared gives us 4, so 4a. And then this is negative 2b. Right, negative 1, and then multiplying 2, so that's negative 2b. And then this is 0 minus 1, right? So that gives us minus c. Right, so that implies that we are going to have, for the expression, now we know that our a, right, so let's move this here. We know that our a, or the a part of our question, right, we got a to be equal to 1, right, and we know that our c is equal to 2. So we'll substitute it here, and that implies that we have 4 to be equal to 4 multiplying 1 minus 2, right, multiplying the b, which we don't have. We don't know b already, so b is b, right? It's c that we know, so minus 2. So that implies that we are going to have 4 to be equal to 4 minus 2b minus 2. So we can have, right, 2b, where we move the b to this side, is equal to 4 minus 4, right, minus 2. So it means that 2b becomes equal to, right, negative 2. 4 minus 4 goes to 0. So we divide both sides by the coefficient of the b, which is 2. And that implies that our b becomes equal to negative 1. So therefore, we can write our expression 5x plus 4 all over x minus 1, right, x plus 2 all squared, as having a, right, and what is a? We have our a to be 1, so that will be 1, right, all over x, right, minus 1, right, and then we have minus b is 1, so negative 1, so minus 1 all over x plus 2, right? So as we arrange it, especially in terms of resolve, when we resolve it, right, and then plus our c, right, and we know that our c is equal to 2, so c is equal to 2 all over, right, x plus 2 all squared. So once we find a, b, and c, we must rewrite our expression in a partial fraction form, right? Putting in all the values of the variables a, b, and c, right? So let's consider this. So this example, x squared minus 17x plus 57 all over x minus 1, x plus 2 all square. You try it out. Make sure you try it out and then write the solution in the comment section. In this lesson, we have basically gone through the process of resolving rational functions into partial fractions, and realize that with this, we are looking at repeated factors. But then we looked at an example which combined a linear factor with a repeated factor. In our next lesson, we want to look at how we can resolve rational functions into partial fractions, where the denominator cannot be linear and is also not repeated. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.